Have you ever wondered why almost every trigonometric formula comes from one simple equation? Without it, there are no double-angle formulas, no half-angle formulas, no power reduction identities. Even many calculus integrals become difficult. Today, we'll discover why this single identity became the foundation of all trigonometry. Everything begins with a right triangle. Let the angle be theta. The opposite side is A, the adjacent side is B, the hypotenuse is C. From Pythagoras, a squared plus b squared equals c squared. Now divide every term by c squared. We get a squared divided by c squared plus b squared divided by c squared equals 1. But a divided by c equals sine theta, and b divided by c equals cosine theta. Replace them, and we get sine squared theta plus cosine squared theta equals 1. One equation that built all of trigonometry. Now watch what happens. Suppose someone asks, what is 1 minus sine squared of x? Don't memorize it, just rearrange the identity. You get cosine squared of x equals 1 minus sine squared of x. Move the other term, and you obtain sine squared of x equals 1 minus cosine squared of x. One equation has already produced two more. Now consider this integral. Integral of sine squared of x dx. It doesn't have a direct formula, but this identity changes everything. It gives us the half-angle identity, which turns this difficult integral into an easy one. That's why this equation appears again and again in calculus. Double-angle formulas start here. Half-angle formulas start here. Power reduction identities start here. Even many ideas in physics and engineering start here. One equation connects them all. Today, we didn't just learn a formula. We discovered the equation that quietly supports all of trigonometry. And in the next video, we'll answer another fascinating question. Why doesn't sine of a plus b equal sine a plus sine b? The answer is more beautiful than you might expect. I'll see you in the next lesson.